So let's start the discussion, and as we discuss, like, um, in the first part about the acid, and what about the uh, how the the first part about the acid, and we also discuss so we also discuss about the different characteristics and the different important reaction. Now let's quickly sum up the acid one, okay, on the revision side. So acids are basically, as I said, naturally occurring in the two different form. One is like natural source, another is um, like organic or the inorganic. Okay, so some of the natural source acids are like orange, okay, and apple, tomato, you know, tamarind, sour milk. Okay, these are the acids. And acid acids are acid forms or acids present in other form, which you should remember. One is called citric acid. Second is your malic acid. You should remember the formula. Oxalic acid, tartaric acid, okay, lactic acid. A lot of questions might ask acid, okay, lactic acid, and then acetic acid, and the last one is amino acid. This is all there in your syllabus. Okay, so the organic acid, as I said, organic acids are present in um, animals and the in the living organisms, okay, and planets and all. For example, acetic acids and citric acid and acetic acids are the example of your organic acid. These are organic acid, okay, uh, and the minerals and all. So those acids which are the mineral acids are, so mineral acids are the, this is also known as the inorganic acids. So inorganic acids or the mineral acids, basically they obtain from the minerals of the earth, okay. So for example, examples are H2SO4, okay, H2SO4, HCl, HNO3, and etc. So this organic acid, these are also known as weak acid, okay. These are the weak acid, okay, and these the inorganic acids are also known as the strong acid, okay. I hope and these strong acids are very harmful, okay, and they are basically harmful in more harmful in the concentrated form. So we normally handle these acids very carefully, okay. So you might have asked question like how you make the issue acid dilute, okay. So normally we don't add water to acid, rather acid to water, rather we add um, water to acid, okay. And so that's the very important questions. When we do the question answer, we'll do this thing, okay. So some of the use of your acetic acid, I can tell you here only. Acetic acid, this is also called as a vinegar. So this vinegar is used in preservative for making. These are as a preservative. They are used in pickles, making pickles. Okay, and tartaric acid is, they are the ingredient. Okay, and tartaric acid are basically used in if you remember, they use in the baking part, they use as an ingredient of the baking cakes and all. carbonic acid present in the drinks. So remember all these things: carbonic acid. So the Coke and soda, the drinks, what we use, drink basically Coke, you know, all the Coke, Cola, these are carbonic acid. Okay, and the soft drink, all whatever is come. Okay, now some other topic. What do all the acids have in common? Okay, so some common acids and their chemical formula. Acetic acid, I have already told you. So the formula is CHHCOOH. Okay, so this is your, sorry, I wrote it in the wrong place. So acetic acid I say. So acetic acid is your CH3COH. Yes. Okay. Anna? So some other acids, I'll give you the formula if you remember. Otherwise I'll put in the notes, like hydrochloric acid, sulfuric acid. So acetic acid, as I said, acetic acid is your CH3COOH. Okay, and formic acid, they have formula is COOH. Okay, and carbonic acid, the formula is S2CO3. So these are very, very important. And the last one is also very important as per your syllabus. There is phosphoric acid. So this is S3PO4. Okay. So basically, what is the common? So they all acids are substance which contain hydrogen. Okay. So you say they all contain hydrogen. Okay. And when they dissolve in water, and they give H plus ion, okay, when dissolved in water. So this is the in water. So this is the common. So they all give the H plus ion when they dissolve in water. Okay. So this you have to remember. Okay. So but all the hydrogen containing compounds are not acidic. Okay, so if they give iron, and that is the reason that conduct electricity, but important something is there where you should remember. I'll not discuss in detail, like, but few of them are there. They do not give H plus ion. Okay, like ethyl alcohol, ethyl al ethyl alcohol. Okay, so CSC2H5OH. Okay, and glucose, and glucose. Okay, glucose formula C6H12O6. Okay, so they contain hydrogen. They also contain hydrogen. Also contained hydrogen. Okay, but they do not give H plus ion, but do not produce H plus ion. Okay, so that is the whole point. Okay, so they are not acidic. So they are not acidic. So they might ask you in the objective. Okay, so one more question which is normally asked: rainwater. So why rainwater? The question is, rainwater conduct electricity, but distilled water does not. So why? Because the distilled water, because they do not they are impure water, because and rainwater contained it basically when the rain drops comes, okay, he goes through the atmosphere and get a lot of gases like CO2, SO2, NO2, etc. Okay, so CO2 dissolve in H2O to form carbonic acid, which is dissociate to give H plus ion. Okay, and hence this conduct electricity. So CO2, what happened? CO2 basically dissolve in CO2 dissolve in H2O, okay, and give and form H2CO3, okay, which further dissolve and give H plus ion. And that is the reason why it's conduct electricity. Fine. So you remember that is the reason why the rainwater conduct electricity, but distilled water is a pure water. It does not have electrons in the free state form. Now one another concept, important thing which is normally asked in SCl, okay, said that SCl gas is not acidic, but HCl, but acidic, but I'm sorry, acidic in presence of water. So what happened, if you remember one experiment we did in NCRT. So when we took litmus paper in the in front of the HCl gas outlet, okay, so the litmus paper remained unchanged, but when the same litmus paper we dip into the water, is wet, and take in front of the HCl gas, it turns red. Okay, so why it's so? Okay, so this is why, because you know, like uh, and there's a very formula famous, because in the gaseous state it does not in the dry, because it needs a water to dissociate H plus ion. Okay, Anna? So if you, so that is the reason why it does not dissociate ion when it is dry. Okay, so like uh, HCl gas, you know, when is react with water, just for your knowledge sake I'm putting, it gives S plus aqueous ion, okay, and Cl minus, okay, is break. But when it is gas, okay, it's break into what? It's break into S plus, and this cannot occur. This is cannot occur. Okay, and that is the reason why it does not. So the reason why HCl spills into and plunges of water. Okay, so you that is only you have to remember this. This normally comes in the this name. Okay, and as I said, when how dissolve the concentrated acid, when acid is added to water in a breaker, we have to be seeing like it has to added uh, acid water to acid, not acid to water. Fine. So these are the some few important points I just wanted to discuss with you on the acid part. Now quickly let's go back to the base. Okay, so what is base? Okay, so base is like again the general characteristics of base is what? So base is, it is again bitter in taste. Okay, it is bitter in taste. Second, it is slippery means is soapy touch, huh? Okay, it turns blue litmus. Okay, litmus, it turns blue litmus. Okay, and he and turns phenolphthalein solution pink. Okay, and this is also corrosive in nature. Okay, so like acid also corrosive in nature. Fine. Okay, so it does conduct electricity. Fine. Okay, now these are the very standard what we have seen in the case of acid also. Okay, Now few part, okay, now few is like metal, reaction with metal, reaction with metal. So reaction with metal. So similarly, like acid, it's also react with the metal and give hydrogen. So take an example, 2NOH when react with any metal, it's form metal oxide and water. Okay, so react with metal and liberate hydrogen gas. No, it liberate hydrogen gas. This is sodium zincate. Fine. Okay, I hope I'm clear to you. Okay, so it reaction with non-metal oxide. Okay, so when base react with non-metal oxide, okay, so it's again form salt and water, H2O, water. Okay, for example, I'll take calcium hydroxide. Okay, when react with metal non-oxide, which is carbon dioxide, form CaCO3, and this gives water. So this is nothing but salt. Fine, I hope I'm going little fast, so we can cover everything in 1 hour time. Okay, so second is more about base. Okay, chemical nature of base. Okay, so more about some other property of base is what? A base is the substance which dissolve in, so like other property. So what we said in the case of acid, so what we said, acid dissolve in water and it gives H plus OH. Okay, then base is dissolved in water and it gives OH. Okay, so for example NaOH, okay, when it react with water, so dissolve, it gives sodium aqueous, which is H2O, please don't get confused, and it gives H minus ion. Okay, so similarly, if you remember ethyl alcohol and other example, okay, it ionize in aqueous solution but gives hence they are not base. Okay, now second important point is again here the difference between base and alkali, base and alkali. Okay, so what is that? So base and alkali is this base which is dissolved in water and gives hydroxide ion. Okay, so those base which dissolve in water, base dissolve in water. Okay, so base dissolve, or they are soluble, that as I said, soluble in water. Okay, and give hydroxide, hydroxide OH. Okay, and they are called alkyl, and these are alkalis. Okay, it's like base, as a base is the substance which neutralize an acid, therefore sodium carbonate, sodium hydrocarbonates are also considered as a base. Okay, now here for example in this case carbon dioxide, MgO, okay, these are the NaOH, these are the alkali. Okay, now so all metal hydroxides are base. What does mean? This means that base are oxide and hydroxide of metals. Okay, but though the hydroxide of metals it to be a base. Okay, so alkali we have seen already what is alkali. Okay, now one important thing you must know कि ammonia used in household in alkaline in nature because it's dissolved in water to form ammonia oxide, which gives hydroxide ions. Okay. Now next is neutralization reaction, which is very important, you know. So I hope you able to understand the difference. Okay. Now C is neutralization reaction. Neutralization reaction. We have already discussed earlier, just for your sake, when it's react with acid, the base, it gives salt and water. Salt and water. Okay. So this is called a neutralization reaction. Okay. So basically, if you look at very carefully, you know, like NaOH, then it's react like I'll give you first the real equation. NaOH when react with HCl, these are aqueous, this is aqueous, and react with NaCl, okay, plus water, right? This is liquid, this is aqueous. So, and this is salt, is from salt. Okay, this is base, this is base, this is acid. Now what happen internally? Basically sodium, say, is basically this is of broke into this two, and similarly HCl is H plus and Cl minus, and when is further is after the reaction this Na plus Cl minus plus H2O. Okay, hence these are the neutralization reaction, because the reaction between H plus ion gives by the acid, okay, by the OH ions gives by the acid, with OH ions gives by the base to form water. So basically these two they mix, combined, and they give this one H2O, and that's the reason it is a neutralization reaction. Okay, so now it is also something you must have heard about the exothermic processes. In there, exothermic reaction which takes out the heat. Okay, you exert heat. Okay, so basically base, mixing of base with water is an exothermic process. Exothermic process. Okay, so only this you have to you remember exams and point of view, since there is a revision. Okay, so that's I think we are coming to close to the base. Okay, now some of the very common bases which very important on exams and point of view से this part है ना, आप लोग बड़ा ध्यान से कीजिए, because like some base is okay, some base is there, okay, like so NaOH, okay, that is sodium hydroxide, and what is the commercial name? So the commercial name is caustic soda. Okay, so this is used in soap making, okay, and then artificial fiber, okay, and rayons and all, like artificial fiber like rayons and all, these are the artificial fiber. Okay, now second is potassium hydroxide. This is also called caustic potash. Okay, this is used for soft soap making. Okay, and then in battery industry, okay, for absorbing the carbon dioxide. Okay, now next is calcium hydroxide, which is very famous base, and this is called as a commercial name is slate lime. Okay, So this is used in making bleaching powder, bleaching powder. Okay, and which is used in the olden days, used to use in whitewashing, whitewashing. Okay, okay, and we discuss, so we'll not get into a lot of that. Milk of lime, other one is MgO2, milk of magnesia of milk of lime also we know. Okay, milk of lime or milk of magnesia. Okay, so magnesia and milk of lime is, they are used as antacid. Okay, so to neutralize the acid in the stomach. And the last one is your ammonium hydroxide, NH4OH. Okay, and this is used in removing grease from cloth. So these are very important. Okay, so now the few things are also very important. So weak base. Okay, so we some, like we discuss HCl, HNO3, H2SO4, they are weak, acid are there. Okay, so similarly like acetic acid and phosphoric acid, they are also a weak. So similarly here, so base is, what is basically base is basically dissolved in water and dissociate OH ion. Okay, that's what we know, and that's what we call this a strong and base. So few are there which are basically they are very strong. Okay, like uh, one thing you should know, that greater the OH, the greater the basicity. Okay, like NOH and COH are the strong basically base, because they NOH they react with water and give N plus aqueous, okay, and OH minus. Okay, similarly QH does the same thing. Okay, but some other are there when they do not do, like NH4OH plus water. Okay, this form ammonia, okay, plus OH liquid. Okay, so such bases are, they dissolve only partially, they do not they dissolve partially. Fine. I think it is very, so this is the reason, only you have to remember. So those who are not completely dissolved, it is the weak acid and the weak base. Okay, so so by this we have covered the your acid and base. Now the next part is salt. So salt is very small portion in our syllabus, not much. Okay, so salt is what, when acid and base, they meet, they react, they form salt. But what is salt basically? So salts are the ionic compound. Okay, they are the ionic compound. So, and they are consisting of two part. Okay, so it has two part. One part, part one, okay, which carry a positive charge, okay, called the positive ion or the cation. Okay, which call positive ion or cation. Okay, now second part, okay, are called second part. Part 2 is carry a negative charge. Okay, so and this is known as negative ion or anion. Okay, this is known. Okay, and some of the common formula. Since it's a revision one, I'll not get into a lot of deeper stuff, like, but few things I give you. Few salts are common salts are NaCl, okay, Na2SO4, okay, NaNO3, okay, KNO3, okay, so CuSO4, okay, NaNS4, Cl, okay, no? And how we form salt? So salt are few point you some remember. Salt are formed by neutralization reaction. Okay, so we have seen many example I've showed you. Okay, and similarly, uh, by action of metal on the oxide, we have already seen metal when react with acid. Okay, so salt is formed, salt and water we have seen. Okay, Zn plus H2SO4, so we have seen ZnSO4 and hydrochloric acid liberated. Okay, similarly by action of acid on metal oxide. Okay, now when metal oxide or metal carbonate or bicarbonate, first I'll take this one, carbonate when react with HCl. So again we have seen this all reactions in salt, so they form salt, H2O plus carbon dioxide. So this is CaCl2, okay, and water and this one, fine. Okay, and similarly by the action of the third one is by action of metal or alkali. Okay, so this is the way the salts are formed. Okay, so few more salt based on acid. So this is what you should remember. Okay, now I think we are almost come to very closed. Okay, and strong, we have already salt of strong acid. I'll put it in the notes and all, you have to look into the notes. Okay, so strong acid, salt of strong acid is what? Salt of salt of strong acid. So salt of strong acid is, okay, your like strong acid and strong base, I would say strong base is NO2CO3, okay, NaHCO3. so this is the lot of information you have to remember. Acid base salt, and in your chemistry it has a lot of weightage. Okay, and salt of weak acid and weak base, what is that? Weak acid like CH3 and ammonium acetate, okay, COONH4, fine. So by this I think we have covered all the most important which is need to be completed, and go through. Okay, so after all the exercise is done, then I will basically will cover your major main question answer. Okay, thank you very much, and I hope you like this session. Okay, please subscribe us and motivate us. Thank you very much.